Today we're going to look at atoms. More specifically, what an atom is, what makes up an atom, the structure of an atom, and how to calculate subatomic particles. Let's begin by looking at what an atom is. Atoms are the smallest particle of a chemical element that can exist, being about 0.0000001 centimeters wide. If we put that into some context, the number of atoms you'd need to stack up to make the thickness of a crisp or a chip is the same number you'd need to stack up to make the height of Mount Everest. Wow, I know that's a lot of crisps, 7 million to be exact. So what makes up an atom? Well, atoms are made up of 3 even smaller particles, which are called neutrons, protons, and electrons. Now that we know what an atom is and what it's made up of, we can look at how these form its structure. Those white lines surrounding the center of the atom is known as the electron shell and is where the electrons spread out and orbit the nucleus. The nucleus is the dense core in the center of the atom. Within this dense core, you can find both protons and neutrons. So now that we know what an atom is and how it's structured, we can begin to look at calculating subatomic particles. So each particle has 2 properties, a mass, so how heavy it is, and a charge. This can either be positive, negative, or neutral. If we look at the proton in the table, you can see that it has 1 for mass and a positive charge. Whereas we look at the neutron, it has the same mass but a different charge, as neutrons are neutral. Lastly, electrons, these have almost a 0 mass and a negative charge. An easy way I find to remember the charges is pro for proton is positive, pro for positive, nu for neutral, neutron has nu, and electron is the only one left, so it is negative. So if we look at an element on the periodic table, for example, carbon, we see that it has 2 sets of numbers and a letter. The C is carbon's element symbol, and this is how it is represented in chemical formulas. For example, CO2, so what we breathe out, the C stands for carbon, and the O stands for oxygen. The 6 is carbon's atomic number, so this is how many protons the atom has. In an atom, you have the same amount of protons and electrons, so this 6 also represents the number of electrons in the atom. The 12 is carbon's atomic weight. So remember how we talked about the weight of protons and neutrons? The number is those 2 added together. You might be wondering what happened to the electrons. But if we remember, the electrons have a almost zero weight, so they're not included in the calculation. Okay, well if we look at some of the equations now, which help us work out both atomic weight and atomic number of an element. Again, we'll look at carbon as our example. If we want to find the mass number, which is the 12, we need to plus the number of protons and number of neutrons together. So if we had 6 protons and 6 neutrons, the weight would be 12. But what if we didn't know the number of neutrons? Well, we can subtract the atomic number from the mass number. So carbon has a mass number of 12, we take 6, and that means we get 6. This means that carbon has 6 neutrons. And like we said before, the atomic number is the number of protons in an atom. An overview to make sure you are all listening. An atom is the smallest particle